And we're recording. Welcome to the evening of Python coding. Once a month, we come here. Many people gather from many places, and we go online and look at some demo of some library. Uh, Tonight, we will have Jeremy Langley again, once again. He's been with us for many, many years, and we're happy to have him again to show us a library called NetworkX. We already talked about NetworkX a while ago, but it's kind of interesting to have a look at it again, especially for beginners, but not only. So, Jeremy, tell us about NetworkX.
Yeah. Hi. Let's see. This is going to be a beginner talk. Let's see, beginner friendly. So if you're just starting out on your journey, this is a wonderful way, especially if you come from a non-computer science background. So in computer science, we're taught about different structures, and this is, let's say, a superstructure on which to place a lot of those structures, and we're going to talk about each one of those structures later on. So this is a way to think about coding problems, and let's see, there are two major representations. One is graphs, and the other one is databases. If you're thinking of being able to add people to a list, it could be that databases could be the way to go. But if you're thinking about how things are related to each other, that's whenever graphs come in. NetworkX is all about creating structures that have nodes and edges. That's all we're going to be talking about here tonight, just nodes and edges. Let's see. So I have some setups here and imports. NetworkX is one of them. Matplotlib, because without Matplotlib, we wouldn't be able to see anything. I also have some NumPy in here, and we'll be able to use that later. It's not as essential as the rest, or as NetworkX or Matplotlib. So to be able to get these to display properly, you have to do this Matplotlib inline part. So I'm going to explain the different types of NetworkX graphs using social media. So how many of you, let's see, hopefully you're familiar with Facebook, made a friend or two on Facebook, or 400 is the general average. So what I did was I created an NX graph. This is the most basic type of graph. These graphs have undirected edges. Whenever you create a friend relationship between Alice and Bob, it's created for both. There's no, let's say Alice and Bob are friends, Bob and Charlie are friends, Diana and Eve are friends, you know, that kind of thing. So what I'm doing is creating the friendship pairs here and adding the edges from these friendships. Let's see, quick note, if you want to skip over the users, you don't have to add the nodes. You can just add the add edges from friendships. And if the name doesn't exist in your node list, it'll add it. So it's this is overdone, yeah, but I wanted to show how you could add nodes and add edges. So it'll say, here are the nodes, here are the edges, and it shows each one of the edges as a tuple. So you can have more edges than nodes. That's pretty common. So the next part, this next cell, if you're not familiar with Jupyter Notebooks, you can run each cell independently. So plot figure, this enables me to get a larger figure size. And this is more telling what the configuration of the plot that I'm going to make is. So NX draw, here is where I put my graph in. So I've made this graph and it's in memory, and now I'm using that Matplotlib library to draw it out. So with labels, you can specify the node color, node size, and finally we get Facebook. No, let's see, Facebook early days. So you can also make Facebook with MySQL databases, which is what they originally did it with. So this the structure is different between a database and a graph database. Databases are optimized for machine use. Graphs are optimized so that it's an abstraction so that we can think about it well. And whenever you say plot show, let's see, it renders the graph. So far, any questions about Facebook? Or the normal graph relationship? It's pretty simple. So, all right, we'll move on to Twitter.
Wait.
Yeah,
what databases do you use?
What databases do I use? I use Postgres. Let's say solely. So I use this in a Docker context. You can use it on a managed context. You can have somebody else run the database, and then you just take charge of the data. I'm not doing that yet, but whenever it scales to be larger than a certain number of people, then it'll be necessary to run it on somebody else's managed database. So you'll need access to larger and larger data stores, that kind of thing. So if you're going to use graph databases in production, I would suggest a company called Neo4j. And they run production databases. Not every project is built with, let's say, with that in mind, but whenever you're building a project from the ground up, Neo4j is great. It's got tools to be able to create databases easily. And so I like using the user interface a lot better than I like NetworkX. So, but I don't usually build graph databases manually, where I'm manually clicking on things to be able to create these databases. I'm usually doing it like we saw up here, is adding my friendships and just adding it from a set of data that I already have. So.
Yeah. One more thing, if you use Neo4j and you want to create graphs there, then the graphs there, unlike NetworkX, what is showing now at least, is you can actually say the relationship. Like, for example, you can have relationships between people who are family. So Bob may be a brother of Alice, or you can have like friends. So you can say Bob is a friend of Alice. And this is like the edges are related to different things. So this is, and then later you can query things about family members, friends with some other families and stuff. This is what the graph database will allow you to do. What he's showing now is much more basic. It's much lower level than the sophisticated graph databases like Neo4j can do.
Yep. Let's see. I love to be able to teach. Let's see, at starting from zero. Let's see, or as close to zero as I can get, so I can remove the amount of prerequisites necessary for this particular talk. So it is. Now, each one of these nodes has a dictionary associated with it. So you can store data in that dictionary. You can have a phone number, an address, that kind of thing, as well as the link itself. This node, this edge that's between Eve and Frank, can have its own dictionary. And so they can say, while they are friends, because we're on Facebook, this friendship has lasted since, here's the starting date. So each one of the, so now you can query based off of that, the data in the dictionary, and say, how many of these links are older than 5 years? So now you can, now some of these edges will drop off during your query. So let's see. All right, so we'll move on to Twitter, and it uses a different type of graph relationship, and it uses a digraph. A digraph is going to be directional edges. So this has the ability to, let's see, for Alice to be able to follow Bob, and Bob not to be able to follow Alice. So we've seen that on Twitter. That's why I use that. And whenever you graph it, it'll have these arrow pointings. So once again, the data can be stored in each one of these edges, just like let's say, just like the other graph. There are two other types of graphs left to go. I'm going to talk a little bit about the spring layout. You need to be careful about using this spring layout. It works fine for very small graphs. Whenever you get past 100 or so, this spring layout isn't going to work so well. You'll just get this this hairy ball. Everything is in the center. Nothing's really going to be expanding out from that. So it's, let's see. You might have to specify the positions. And so in here, I'll say later on, I have positions specifically specified, but you can do that with the pos argument here. So we're just using the default spring layout. If I re-render this, it might re-render it differently every time. So it's going to look different. All right, the third type is a multi-graph. And so this is like if Facebook had multiple relationships between two people. So we see that Alice and Bob, first and second line, they have two relationships, a friend and a colleague. So this can be multiple edges, each one with their own data. This didn't have to be like this. You could have specified one relationship and be able to say in that list of data, say this has friend, this has colleague. But if your mental map needs the extra relationships, sure, go ahead and use this multi-graph map. And so, once again, yeah.
So this is more like Neo4j, what you're doing now.
Okay.
Neo4j allows you to actually specify the type of relationship, just like what you're doing now.
Yep. I'll say it will look the same. Let's say it's collapsed all of those multiple edges into one, and so let's say there's a way with curves that I was playing around with later on, and I'm not sure if that would work with multiple edges to the same two nodes, but I will try that one out later. It's one of the questions that I'm looking to solve in the future. But the user interface, as far as the graphing goes, has gotten a lot better in recent years. So the arrow style looks great. The lines look great. So it's the last one is a multi-digraph. It's the same idea, multiple edges with direction. So now let's see, it looks the same, but notice that there are at least two edges, one from Charlie to Bob, another one from Bob to Charlie. And so that's why we get two arrows on these, each one of the edges. But as we can see up here, the interaction, let's see, we can message somebody, we can have a like, we can have a share relationship. Anyway, let's see. You can specify any of the node colors. The node colors are based off of the HTML, CSS standards. So if you're familiar with, or the more familiar you are with CSS, the more colors that you have. All right. Now, we're going to get into some computer science data structures. This is stuff you're learning in the 200 classes. And let's say things like linked lists and stacks and queues. It can be, let's say, if you're not taught about graphs, then the linked lists are harder to understand. Let's say, so don't miss out on this superset. So a path graph is going to be one of the types of graphs that can make easily. So a path graph is just going to look like this. 0 going to 1, going to 2, going to 3. You can specify how many nodes. So I've got 5 nodes in here. And you can use whatever type of graph you want. So you can start off with a digraph. You can start off with a regular graph. Plot figure, I'm just changing the size. And it takes no specialized, or let's say I put in an arrow style. You can specify different arrow styles. But there's nothing really special about this other than the linked list can be used inside a graph representation. I'm using a graphing library, and this is so much easier. Let's see, there was one time I did an interview where somebody wanted me to make a linked list. What he was expecting me was to code for the nodes and edges using Python classes and be able to draw the structure. And whenever I pulled out NetworkX and I did this this line, and I did a very simple NX draw and a plot show with using matplotlib, and showed him, let's say, showed him this representation. He's like, no, I want you to do it this way, or I want you to do it the way that I've been taught. Let's see, to his credit, he was a mid-career programmer, and he was trying to control the implementation of the code. And I wasn't particularly liking that aspect of it. And it's like one of my warning signs whenever going into a company. So I said, let's say, or he handed me a slip of paper, which was the requirements, which helped me to start the whole project. I read over the requirements, and this solved the problem. So it'll work up to something like 50,000 either nodes or edges. Let's see, it can do it, and it can do it very quickly in the fewest number of lines that I could have written the problem in. So I said, look at the clock. And it was something like 7 minutes later, or after he'd given it to me. And it's like, we're done. We're ready to ship. Let's get this customer their product. Anyway, so anyway, but he didn't have anything else for me to do for the rest of the 45-minute interview session. I wasn't interested in the particular job afterwards, but let's see. I think I dodged a bullet on that one. So let's see. I did end up because it was rather awkward after that. I'm just like, okay, fine. Here's the nodes or here's the edges, but I treated it like there might be a problem with the implementation. So whenever I said before that it can go up to 50,000 nodes or edges, I say that because that's how many it can display whenever it draws it out. Now, the drawing mechanism and the ability to store this graph is completely separated. So don't think that, let's say, that NetworkX has a limit of 50,000 nodes and edges. So if you go over 50,000, I'll say it makes computers crash whenever you want to draw this out. So you have to be able to be intelligent with your selection of nodes. Make sure to filter out what you want during the process. So let me know if you have any questions about that. All right. All right, how many of you've dealt with various tree structures? The tree structures are great for being able to put inside, because this particular library has so many ways of being able to build these default data structures, things like the balanced trees, things like binary trees.
For those who don't know, trees are a subset of a graph.
Oh, let's see.
Graph is nodes connected by edges in no particular order. Trees should have roots, and things cannot go backwards and stuff like that. So there are like no cycles and stuff. So
Yeah.
go ahead, Jeremy.
So
Sorry to interrupt.
I'll give you a, let's see. So that you have an idea of what we're talking about, let's see, trees will generally look like this. They're not necessarily always balanced. Let's say like node 12 might not exist and it'll look kind of lopsided. So that's, this is a balanced tree structure. And I did a lot of work to be able to make it look good after the, why is my mouse is all of a sudden cutting out. So you'll have to excuse me. I'm thinking it's the rendering software for something about Chrome and PyCharm not working well together. So maybe Discord, or sorry, no, it's Chrome. I'm gonna have to stop.
PyCharm. You're using a notebook, so it's only.
And this, sure. Okay. We're back. Huh. Scrolling up and down, all of a sudden I lose something in my screen here. All right. I might have to skip over this cell for some reason.
Why? What's the problem? Like, what are you unhappy with?
Let's see. I'm not seeing the. For some reason, this scrolling is not working. But
the scrolling. What are you trying to show?
yeah. Plot figure size. So I did a lot more work on the display of this one than the actual building of the binary tree. The binary tree, all of those nodes and edges were built using that single call to build a binary, or to build a.
Try to use the arrow keys rather than the scrolling.
Yeah.
Just go inside the cell and move up and down.
Yeah. That's strange right there. Anyway, draw tree.
It's showing you the functions. What's the problem? It's just not showing. It's just scrolling up. So
yeah, it's just a scrolling part. Okay, so I was wondering if it was displaying in the window, and I'm seeing that it is.
No, it's today the editors have all sorts of like scrolly things that like put the top function on top and then allow you to scroll and things to remain on top. I assume it's one of those like libraries that does this.
Yeah. Let's see. There might have been an update that I. Let's see. I put too much documentation there. So,
that's okay. That's okay. Go over it slowly.
Okay. So in this, I've got my tree. Let's see. I'm specifying the root as my 0 node. The width and the vertical gap, I'll say, pretty self-explanatory. And what I'm doing is I'm building up the positions of where the nodes will go. So it's actually looking for XY positions. So let's see. This one I'm having to build up the labels that you're going to see on the on each one of the nodes. So if you want, you can specify multiple node colors. Let's say doing a node or doing a color map is the easiest way. This is Matplotlib has the ability to do color maps. Blues is a series of blues from very dark blue to light blue. There's reds. We'll see a couple of other color maps later on. So I'm being fancy with Matplotlib. And finally, the tree position. This draw if you're looking for how I use any one of these things, look at the draw function and then work your way backwards. Let's see. These are for the annotations on the side. So you'll see level 0, level 1, level 2 over here on the right. So these are all the tricks that I know as far as the plotting goes. So getting them to display properly is going to be the hardest thing about NetworkX. So I spend a whole lot more time trying to figure out how to plot these things than I do working with actual graphs.
So there are actually libraries that will plot things for you, but not at the level of detail of what Jeremy did. GraphViz, if I recall correctly, will do it.
Yeah, let's see. GraphViz is kind of the Photoshop of graphing libraries, and so it is pretty nice to work with. Whenever you want to do selects and that kind of thing, it can plot a whole lot more nodes than the normal NetworkX draw. I would, there is an extent to what it can do on a single machine, but still, wow, it's quite. It's a long-running program, so let's see, a stack. This is what we're thinking about whenever we're talking about a stack. And let's see, the last in, first out. You'll hear a couple of terms: last in, first out, first in, first out, and a network graph is a great representation to be able to hold that stack as well. So far, I'm not going to go into a whole lot about this. I'm going to make sure to use like last 15 minutes for the last graph. So far, did you have any questions about the data structures and how it's used in data science on low-level stuff, a database? Okay. Checking the chat here, so just in case.
Well, I'm checking it for you. There's no one answering. They're happy. You can go on.
Good. Let's see. Double-ended queues. This one I needed to draw the arrows in. Let's see. But double-ended queues means you can go back and forth between elements if you need to manipulate or get from the left end to the right end and back. Let's see. Go to element 1, decide, do I need to go back or not? Let's see. Oh, I forgot to mention the another data structure that has been used with, let's see, with a linked list is blockchain. So they added encryption to a linked list. So it always refers back to the last or the last block, and they make sure that that block can't be changed. It's let's say I might have the edge wrong in the wrong direction. So I'm thinking it goes backward to the last block. So
well, let's stop here for a second.
Sure.
Do people know what a blockchain is? Come on, say something, someone. Like those who know what the blockchain is, can you like explain in more words than what Jeremy did? Justin, you want to say something?
Blockchain just is a way of confirming data that came in there, and everything has to work out, and it's redundant basically. So that way, as new information comes in, it's got to be checked with the old information that's already there.
Okay,
as I
so
understand it.
You described the characteristics of what it is, but you didn't describe the data structure. What Jeremy is showing you actually how it's implemented. Or actually, it's not exactly how it's implemented, but like it's a basic idea of what actually how it's implemented. And he's showing you something very basic. It says, okay, this is very similar to blockchain. So the verification you were talking about is actually the encryption that Jeremy was talking about. So the idea is that now each time you add a piece of information, it's first of all, it's related to something, but then it's also encrypted, and multiple people can go at it and verify that this is correct. So what he's showing you is something very, very, very simplified that is basically like the data structure that you might have. The systems are much more complex, but you understand what he just did? Jeremy, go back and show them the graph or like.
Okay.
So in a blockchain, each time you add a block, it sits on top of the other transactions, correct? So you have like all transactions, it's a ledger. And each time you add more transactions, they sit on top of the previous ones. So basically each node is a set of transactions that happened before. And what he's saying is that, yeah, it's just encrypted. So this is the simple way of doing this. The way they do it in blockchain is a little bit more complicated because you have to verify by multiple people the encryption and stuff like that. But what he's showing you is the basic idea behind it. Do you understand what he was showing then now a little bit better?
Let's see.
Yeah, Jeremy, show him something.
Let's see. Command NX. Oh, I'm gonna do all the.
Don't worry about the reversal. This is like it's
Okay.
just show him what you were talking before, and now in the context of a blockchain, a bigger blockchain, explain what was going on.
Yeah, I needed the reverse because the NetworkX, sorry, the links in this case are reversed. So
forget the reverse ones.
Right. So the older ones are going to be at the very beginning. Then after all the data comes in, it's encrypted. It's, let's see, you want to make sure that all the data is there. So let's see, you take this zip file. Please excuse me for oversimplifying this. Let's see, you take a zip file and you make sure that it has an encryption and you place that that encryption value. You can place part of it in here saying it is, or this is the encryption, or this is a SHA hash. It is the hash that will work for
it's some sort of code that represents whatever was the data there.
Yeah.
And now you have it on the graph. It's part of it's called the blockchain. It's part of the chain. So now on that, the edge has this code. And if everyone has the same code and everyone agrees, then you know that this is valid.
That key is also brought in and saved as part of node number 1. It's part of its data. And whenever it's encrypted, that one, let's say, also saves its encryption information and gives it to the next node. So node 2, if you ever needed to work your way back like a zipper, node 4 has information about node 3. Well, how does it know node 3 is accurate? What if it was changed during the process? Well, yeah. Node 4 has information about the file size of the zip file and what characteristics of the file it has whenever it's zipped and encrypted. So it knows if node 3 has been changed. And so if it has, something's wrong, and get another copy from somebody else. Yes, somebody who tried to mess with that.
This is where the blockchain comes. Multiple people see that graph and they all verify it. And if someone has a different copy of this thing than someone else, then either the majority kind of rules what is the correct blockchain, and everyone else is kind of like a counterfeiter. Well, I'm not exactly. I'm explaining in lay terms, but it's much more sophisticated than this. Michael actually knows more about blockchain. He may tell us later, but like this is the basic idea.
Yeah. I want to.
So you have multiple people see this graph structure. So what Jeremy is showing you is actually how things might be. I'm saying might be represented at the lowest level, and it's essentially some sort of graph. That's it. This is what he's saying.
I'm not saying they did use NetworkX, but they should have.
Maybe they did. Who knows? It's like maybe there's some NetworkX implementation in some like crypto coin or whatever. I just don't know.
Yeah. All right. So let's go to. Oh yeah. All right. So stacks, another default computer science type thing, and I'll say double-ended queues. They can all be done with this graph architecture at the highest level, and they can be done so much more simply than building another, building up your Python classes, and you can just, there's no need to reinvent the wheel. So, all right, so we've talked about graphs, digraphs, multigraphs, and multi-digraphs, and you now know what the different types are and why you would use them in what contexts. So we took a look at the path graph. Acyclic or trees, or acyclic graphs or trees, they didn't have any nodes connecting in a circle. That's
so
all.
Acyclic means no cycles, meaning, yeah, no circles.
And let's see, some specialized layouts. Basically, you can take graphs and make them limited in some way, because graphs is a higher level abstraction. And if you limit them in some way, then you can get the architectures for stacks and double-ended queues and those kind of things. So now, how am I using it?
Okay,
And
tell us first what you're doing before you.
Let's see. What I'm doing is I'm trying to break up university courses into individual concepts. Put those as the nodes of the graph, and then find out what is the fastest way that you can learn a particular subject. So
here, for example, give you an example. Let's say you're talking about history class, and in the history class, they teach about the French Revolution. So the concept will be French Revolution, and History 101 or French History 101 will be the course. Okay, am I correct?
Yeah. Let's say we can, let's say French history might, and let's say is kind of an overarching concept. It's more of a category. We might need to talk about a particular specialized portion of it. Let's say Plato's writings that influenced French history in 1776. I mean, it can be really that specific. But that might be a higher level concept than something that's more basic. So I'm going to use Python as a example here. And so these are the nodes here are going to be things that can be learned in Python. So strings.
It's too small. Can you just point at one and say what it says, because I cannot read it.
Okay, so down at the very bottom, we've got operators, types, and variables. These are programming language specific stuff. It's not necessarily Python. And then there's strings, numbers, indentation, booleans. If you don't know indentation, you don't know Python. Anyway, but you have to know indentation before you know loops. So each one of these, we're getting higher and higher level. Now, there's been some things that have been left off. This is oversimplified, and let's say like dictionaries doesn't have a connection to the none value. So if you're doing a dictionary, a .get operation, it doesn't, let's see, it doesn't have any link to this none value. Now, I need to add that in. But this particular teacher of Python dictionaries didn't add that particular link in as a prerequisite. So because of this visualization, I can see where I need to apply pressure. I need to put in a question into Python dictionaries that highlights the relationship for, let's see, for Python dictionaries to get this particular teacher to put in that node relationship, that prerequisite. So let's see. Is there anything that you would like to know inside Python that's not covered in here?
You're asking us to actually give you an example about something that's related to Python?
Yeah.
Okay, is libraries here or packages?
Yeah, it's just pure Python. So
import statements are part of Python, so the idea of packaging exists. Okay, so you have it here.
We've got imports, so that's great. What do imports need? Imports need some generators, and also variables is one of their, let's see, is one of the prerequisites. So
okay, so basically what you're saying is like if you want to learn only imports, then you have to learn those other topics, and this graph shows you those.
yes.
Okay, so if tomorrow you have a problem of not understanding something in Python, you go to this graph and you figure out which node you're in, and then you go back and say, why don't you understand? Because you're missing something else, like generators in the case of import. And then you have to learn about generators. Why is generators related to imports?
Oh, let's see. The teacher of this imports, let's see. It's either my graph representation or this teacher decided the generators was a prerequisite.
Okay, so you got this information from a certain individual who taught Python. Got it.
Yes. Teachers are able to teach the individual topic and not, let's see, have to worry about anything else. So the teacher who's teaching lists was only put down numbers and strings as a prerequisite. So they didn't think, to put Booleans, but I'm going with them. So you can have Booleans as part of your list. I think
so you have multiple teachers constructing this graph, correct?
That's it. Every teacher teaches their own their concept.
Okay.
So
your idea is to actually take multiple teachers and merge all of their knowledge, so in a way that you can actually figure out which topic relates to what other topics. So if you want to, for example, learn about imports, you don't have to learn all the other stuff. You only have to learn only the basic things of that needed. Like in this example, only generators and something else. What is to learn imports, correct? And variables to understand imports, correct?
According to this teacher, yes.
Okay.
And not this is a simplified version of let's see, the structure, because there could be 5 teachers teaching Python dictionaries, and I'll say I'm only showing one. So
okay, so each time each teacher will have a different graph, correct?
That is right.
Okay, so now if eventually when you actually, your system will allow people to actually go and ask questions about how to know something, and to tell you only the very basic things you need to do to get to understand that thing alone, correct?
That is
and
right.
According to multiple teachers.
Let's see. Right now it's going to be a single teacher, and you don't know which one. I'm going to be following the test scores at the end to find out whether or not you learned the information using the teacher, and whether or not we recommend that in the future. So we've got a recommendation system.
Ah, okay. So you'll be following each time you get some other random teacher, and eventually you'll figure out who the best teachers are as well.
That's it.
Okay. So this is what Jeremy is
doing.
Yeah, and he's doing it outside, and he's showing you in the context of graph what he's doing.
Yep.
You have anything else to show us, or?
I'll say that this is going to be it. So if you want to learn, Python lists, then you need to know numbers and strings, and also operators, types, and variables from other from basic programming languages. And what that what that can do is lists takes about 15 minutes to learn. Numbers takes about 20 minutes to learn. Strings takes about, let's see, 5 to 6 minutes, depending on, let's see, which type of strings that they did, because F strings are up here in the Python 3 features. So I'm going to say normal strings takes about 5 or 6 minutes. And then operators, types, and variables. Now, since I know the time it takes to learn each thing, I can tell you how long it takes to learn Python lists based off of how long it takes you to learn all of this other stuff: operators, types, variables, numbers, strings, and then finally lists. So you don't have to take a class for an entire semester to learn Python lists. You can take, let's see, 2 hours, something like that.
We have some comments in the chat. So I see first of all something about Facebook unicorn control swaps adjacency list graphs tracked with adjacently sorted arrays.
We're going to take this out of beginner territory here. Let's see. Adjacency lists are going to be another data structure to be able to save these graphs. If I wanted to save this graph into a format, I might use adjacency list graph. Adjacency sorted arrays. I haven't heard of this one, so.
Yeah, we'll have to look at it later on. Maybe this is not part of the thing. Unless it's something that we misunderstand. Let's go to the next question. Do you implement cache? How do you implement it? It's kind of, yeah. So, yeah, go ahead. Give your answer. It's a weird question here.
Okay. I'm trying to think about how to make this simple and not go.
Cache is not really a data structure. This is why it's like.
Say Redis a lot. Anyway, let's see. It depends on what your use case is for the cache.
Yeah, but you don't use network. You don't use NetworkX or a graph to implement a cache, correct? Generally speaking,
I'll say, if you want, you could base it off of a stack using the datetime as kind of when elements drop off. So you have this, or the bottom element was inserted first. It has a datetime element. So after 15 minutes, it goes away. So each one of these has a timer. And as you reread, you can delete at the same time. So if the bottom and element 1 are older than 15 minutes, you can delete them off of the stack and continue on with element 2. So with each read.
yeah.
So that is an example of a cache.
Yeah.
Also, that's a time-based cache. There's also a most recently used. How would I implement it? I would use the least recently used, or LRU package. Sorry, the LRU. I'm thinking collections.
Yeah. So network is not exactly for this, but I have more questions.
Yeah.
This seems to be Facebook cache architecture. Yeah. So look, Amir is asking this question. So look, Facebook, it's a huge database. It will use all sorts of tricks. What we're showing you here is how the very basic concept of a graph, like whatever Facebook is actually holding, actually can be implemented in Python. Don't think about the higher structures that Facebook uses to maintain it itself. It's the very basic concepts. So basically, Jeremy is showing you, oh yeah, you can create your own Facebook on your computer. It will not hold. because you can't have billions of users running all the time doing all sorts of stuff. But he's just explaining how it's possible to do very simply at a very small scale. Correct?
Yeah, it's going to depend on what your use case is for the cache, on how to implement it. Func tools. Thank you.
Okay. Yeah. Any other questions? Wait a minute.
How are you, cache?
Yeah. Questions going once? Questions going twice? Oh, here's it. Is the notebook public? Yes, it is. You can actually go ahead and download it. We'll put the link later on the chat. You can look at the meetup announcements and find it. When we publish the video, then the link to the notebook will be available. But basically, you can look at Jeremy's GitHub. It's back to basics, and find it there. You'll probably find some also old memorabilia from previous presentations he made. He made many presentations through the years. Hopefully, some of them are still there.
Let's see. Hopefully, some of them are still relevant. Let's see.
For people learning stuff, it's relevant. If there is a video and yeah.
The sets one, if we can find that one, is still relevant. I think I did a Pi Texas talk, let's see, on NetworkX back in the day, but please don't find that one. Let's see. It's the best one, and part of it has a maze that 1 pixel paths and 1 pixel walls that I tried to solve using NetworkX. And what I did was I made a grid pattern out of all of the network nodes, showing the X and Y position as the name. And so then on all the walls, I deleted all the walls. So if it was a black pixel, I deleted all of those. So that only leaves the paths. So now you can use the NetworkX algorithms and one called star search. Or a star search. It will, you can pick one node, pick another node, and it will find the fastest path from one node to the other. So then, afterwards,
yeah, lots of games use this.
And so afterwards, I knew the names of the XY position of the pixels for the fastest path, and so I needed to draw it blue, each one of those pixels on the original. So that's the best part. So just now you can skip the video.
Guys, any more questions? Questions going once? Questions going twice? Questions going 3 times? No more questions. Okay, in that case, I would ask everyone to please either make some noise or put some characters there, emojis or whatever they are called now. Black and yeah, Michael, you're using the wrong button. No, it's everyone's using the other button. Yeah, okay. Yay. Okay, guys, thank you. We're giving you lots of thank yous, Jeremy, in all sorts of ways.
Thank you.
Okay. So now, when we thank Jeremy, don't go away. We're not finishing everything. We're just finishing the recording parts. We're not going away. So stick around with me. I'm stopping the recording now. Thank you, Jeremy.
No problem.